courses. That'll be on Monday the 11th as part of University Press Week. We're all about celebrating weeks here. And then on Thursday, November the 14th, we'll have the next in this series. And we're going to have an interesting event that evening with Professor Jason Stout from the Visual Arts Department, who's going to talk about what the experience is not only of a visual artist in the creative process, but as a faculty member who has expectations for research, what does a visual artist do when they supply a tenure and promotion package? So we'll learn a little bit more about those processes here. But as I said, tonight, this afternoon, we're going to be talking about transfer students and their experience with research. We have one more panelist who's going to join us while we're underway, but I'll turn things over to Sarah Morris, who's with our Student Success Department. Thank you.
Okay, can everybody hear me? All right, so my name is Sarah Morris. I am the Success Counselor for Transfer and Non-Traditional Students here at UT Martin. So welcome to the Transfer Student Experience with Undergraduate Research. We've got two panelists here today. We're supposed to have a third one join us. We had a fourth one lined up, but she got sick. So unfortunately, she's not going to be able to be here today. We're here today to learn more about the academic research that several of our transfer students have been involved in this semester. And this panel is part of our week-long celebration of transfer students for National Transfer Student Week. So at this time, I'd like to start off by asking each of our panelists to introduce themselves, like tell us your name, your major, and then give us, a brief overview of what your research is about.
Hi, I'm Ella Willis. I'm a junior here. I transferred in my second year from Jackson State Community College. I'm an ecology and environmental biology major, and my research project is involved with trying to detect the prevalence of snake fungal disease in Tennessee cottonmouths.
Hi, my name's Michael Armour. First of all, I'd like to say thank y'all for coming out and showing some commitment to some students like me. I think both of us can say we appreciate y'all coming out. But yeah, my name's Michael Armour. I'm a senior civil engineering student. I transferred also in my second year from Dyersburg State, and what my research was over was a flood hazard study in Jackson, Mississippi, kind of analyzing the effects of certain flood hazard solutions in that area, in the Pearl River and Richland Creek River.
Okay. Can you tell us a little bit about how you got involved in your research?
Yeah, so my first year here was last year, and during my spring semester, I took herpetology class with Dr. Tom Blanchard, and I just fell in love with the subject, really enjoyed all the work we did, especially our field research going out and trying to find different species. And Dr. Blanchard approached me at the end of the semester and asked if I'd be interested in joining this project, which he'd been wanting to do for a while, but had been trying to get some of the more technical aspects of the genetic analysis involved with the project worked out. And so he was finally at a place where he was ready to recruit a student to help with the program. And so he asked me if I wanted to join, and I said absolutely, because it's definitely within my field of interest. And I kind of wanted to use this to help me get ready for what some field research would look like, because that's what I want to do in my career.
Well, as for me, my research was also really department based. I can thank Dr. Greg Nail over at engineering for kind of introducing this idea. A lot of times in our civil engineering department, we have a senior design, and it kind of goes through the competitions, the ASCE competitions, American Society of Civil Engineers. They host a symposium every year, and where we can build a concrete canoe, and we form a team and we build a steel bridge, and we compete in these competitions. And I kind of looked at that throughout my tenure here, and I saw it and I was like, well, that's pretty cool, I guess. But if there's other options, then I'd like to. And I've always kind of had an affinity to water and hydrology and kind of the study of it, the study of the flow of water. All this stuff interests me. And fortunately, Dr. Nail, he is our hydrology and hydraulics professor over there, and fluid mechanics professor. And he does some extracurricular kind of accounting. No, not accounting. counseling. Nope, that's not the word either. But he outsources his engineering knowledge to people, and he kind of got this job where he was a part of, got in contact with Richland Creek Watershed District, which is who this senior design was put through, this research was put through, and they introduced this hazard study to him, and he then kind of compartmentalized it into a senior design project and got a couple of us engineers together, and we showed interest in it, and it was kind of a match made in heaven. So.
Okay. I want to welcome our third panelist. Can you tell us your name and your major, and then just a little bit about your research and how you, it should be on, how you got involved in it?
Hi, my name is Deja Graves. I think some people know me. I am a chemical physics major. I do research with 4 faculty members. I do research with Dr. Violet Bouma, who's a biochemist, Dr. Alexander, who is a physicist, Dr. Thomas Ellington, who is a physical chemist, and then Dr. Lionel Cruz, who's an astrophysicist. So yes, and I do collaboration projects with 2 of my professors on a biophysics project on using a 658 nanometer red light on a cell line on to identify cell growth, and on see whether or not a red LED is better than a red laser. And so we're going to use that and try to see which one is comparable. A lot of companies say that red laser is better or LED is better or safer. We're just trying to do a project and see if which one's better in retrospect. So.
All right. Okay. And you guys don't have to go down the line. You can whoever wants to answer in whatever order can answer these. Can you tell us what you found most interesting or exciting about your research?
I guess I could hit that. So as for mine, ours was a lot based on like public health. So in floods, I mean, I'm sure we all know what happened. You know, east in South Carolina, North Carolina, and eastern Tennessee, and with all the hurricanes that came. And I kind of that's typically an annual thing where we experience where America, South Florida, that kind of tropical area experiences those major flooding and stuff of that nature. And I kind of understood that flooding is a thing that not only happens there, but happens everywhere, and it affects people. Affects people in different ways. It affects people in different magnitudes. And this kind of study where I can look at and analyze how badly an area is flooding. How can I possibly become part of a solution to that flooding? How can I learn to present my findings to a panel of people, to a Richland Creek Watershed District, to professionals in a manner that it seems like, yeah, this is a solution. This is a viable solution. This is cost effective. This is all these things. And that kind of struck home for me, that struck home in that not because I've experienced it personally, but because there have been a lot of people that experience flooding annually, and that's something that really stuck in my head about that.
What interests me to research is, as a scientist, we always wonder why things occur, why things happen, and so research allowed me to learn as a experimental way of putting myself in the position of help discovering the reason why things happen, and help on the long run help others that can't be in the same situation I am in, to discover and find a cure for reasons why things happen. And so my research with Dr. Bouma, I do antiviral work with COVID and RSV. And so we recently just went to London in the summertime, and we were able to meet with a lot of professionals, and they were across clinical trials using pulse blue light, and a lot of and she just recently went to Nigeria, where very poor, not a very poor country, but a very not high economic country, where they're not able to have the same resources we have. They are struggling to find a way to prevent an antiviral way, and so it's just my way of helping her research reach a broader spectrum of people in a more difficult situation. I feel like it's just me helping others that are in a different situation than I am in. So.
For me, what I found most interesting about my research so far is how undocumented the thing I'm studying is. There's very little literature on snake fungal disease, and there's been very few research projects. And so just getting to almost break ground in a way, I suppose, getting to try to learn more about this thing, and it kind of really opens up our project because, when nothing is known about it, we can kind of take it in any direction, trying to look, evaluating multiple things at once based on, location, the sex of the organisms, the temperature at which time we find them, how prevalent they are, things like that. So it's just been interesting to me, literally the scope of the project that we've been able to look at so far.
Okay. All right. In what ways did research meet your expectations or not? Like, were there things that you needed to do as part of your research that you just did not expect when you first started out?
I guess, well, my answer would be to that, yeah, it met my expectations. I mean, I came into it fully realizing that I would have to write an 80-page report on it, and I would have to give an hour-and-a-half presentation to people, and actually I had to give that hour-and-a-half presentation twice in the same day. So that I expected to do all those things, but did I think coming into it that I would be able and have the capability of doing that? No, and that's the staunch difference between those beginning and the end. Coming out of it, I recognized in the beginning that I kind of felt almost a little hesitant in my own abilities to present, like I said before, present in front of a group of professionals my ideas and my solutions and reasons why I chose the route, went about the route that I took, and that really solidified that the experience I got from conducting this research. Not only finding out, going through iteration after iteration of which solution would work, which way, which length, all this other stuff. We can get into that later, I presume, but that part of it, I guess, hitting the professional aspect of it, because that's why we're all here. Research, you want to be able to bring this out into the professional field, and in my particular field, engineering, I'm going to have to present my ideas to people, and I'm going to have to back up my reasoning for why I did things, why I chose this type of material, why I designed it this way, and so that this definitely strengthened my ability to do that.
I would say the opposite, because if a lot of people know, I've been here long enough to be able to graduate by now. I think I was trying to figure out what I wanted to do with my life. I was a health science major to a pharmaceutical science one to now I'm a chemical physics major. So now doing my research with Dr. Alexander, I figured out that not only am I a theoretical / experimental physicist, that I love putting hands-on, helping people in the lab. This is my bread and butter. I learned how to solder things. I learned how to do machine parts, do great things. And I'm like, then when I present my research to other physicists or other students, and they're like, "Oh, you touch lasers?" I'm like, "Most definitely." Like, I was like, "Y'all don't have that?" And they're like, "I'm a physics major. I've never touched a laser." I'm like, "Oh," I'm like, "I have the greatest experience that a lot of people don't get at other schools that have the physics major." And I'm like, they're like, "Oh, you have the most amazing thing in your hand." I was like, "Yeah, I'm grateful for everything I have here." And it's just like, this is what I've come to figure out, that like, at first I was like, I told him, I was like, "I don't really know how to do this." He's like, "You'll learn." I was like, I'm gonna hold your hand a little bit, then as soon I'm just gonna let go and let you do what you need to do. He's like, and now I'm just like, now I know that what I want is to become a physicist, help others who are never had the experience of physics before in a fun way, and I want to help kids and from K through 12 have a physical experience with physics. So that's what I want.
Yeah, I definitely relate to that a lot. I grew up in a very, very small town, so this kind of research was completely foreign to me. I didn't really know it existed, much less that I'd be able to participate in it. So coming here, it's really just been a learning experience at every turn, and I had a similar experience where I did not know how to do anything with the research, but particularly with my supervising professor, Dr. Blanchard, he's been fantastic in giving me the opportunity to learn how to do this while also giving me some of that independence and letting me take on aspects of the project by myself to be able to build those professional skills because as Michael said, that's why we're here, that we want to learn stuff like that. So I definitely relate to both of those things.
Okay. Can you tell us a little bit about your transfer journey? Can you remind us where you transferred from and what drew you to UT Martin?
Um, I went to Union University. I was an athlete. I was on a athletic scholarship. I came from Westview, Martin, Tennessee. I thought the only way I'm going to get to school is through athletics. Then I realized athletics is not everything. I realized my brain got me here some way and somehow. Athletics is just a side part of it. Then I realized after athletics what I'm going to do. I already told them, I was like, basketball is just one part of it, but the other side is my brain. I'm here to get an education as well. And they didn't believe that that's why I'm here. And they said basketball comes first. I'm like, no, my education comes first. So I decided to give that up and go focus on my education at the end. So that's why I'm here, and I'm glad I came here. So
For me, it was absolutely the program. When I was going to Jackson State, I was actually a physics major, and discovered I was not good at it, and I did not I did not enjoy it, and so I had to kind of pivot a little bit. I actually worked at a outdoor STEM education facility during my senior year of high school, and then during my first year going to Jackson State. And I discovered how much I loved the outdoors, particularly seeing how kids respond to outdoor experiences that they were unfamiliar with. And so seeing that really just completely changed my perspective on my academics and my future career. So it kind of switched me the whole spectrum of the science field to biology. And I was trying to find a program that would fit for me and that would fulfill what I wanted to do, which is conservation research. And I found the ecology and environmental biology program here at UT Martin, which is not a program that's super prevalent. And so it was really nice to be able to find that because it had everything I wanted without a lot of the superfluous things that I did not feel would be beneficial to me. So it was definitely the program for me.
Well, as for me, I'm an old head. I graduated in COVID. I graduated in 2020 from high school, and so that my first year of college was kind of a tumultuous one. I started out. I was enrolled at Mississippi State actually for their civil engineering program. I was in their honors program. I was in their College of Engineering, and what actually kind of drove me away from that was, everybody went on online classes. I'm sure, y'all remember that. It wasn't too long ago. But we all went on online classes, and they were going to have me stay on campus and kind of take that route. And fortunately, I was lucky enough to get my tuition paid for, but I did not get my housing paid for. So that kind of those were big red flags. Like, wow, I'm going to pay all this money to go online, and I'm going to be stuck in a dorm all day. So I de-enrolled, and I enrolled in Dyersburg State. And so I spent a year there, and I've always had in the back of my head to do civil engineering. I have two older brothers who are engineers. My eldest brother is a civil engineer, and I've always had it in my head to do civil engineering. And fortunately, UT Martin presented itself in a way that was more geared towards me than everywhere else. Obviously, I come from just north of Memphis in Tipton County, and everybody that I graduated high school with was like, oh, let's just go to Memphis, and my mom, bless her soul, she's like, I don't know about that, but yeah, I got in contact with our engineering department, and Dr. Nip, he was the head of the chair of engineering back then, and he inserted me right in, and he gave me a tour of the place, and I recognized when, hey, I'm getting the head of engineering is giving me a personal tour right now. Are you kidding me? Are you kidding me? And that was kind of like a major, huge green flag for me. And I got to talk to a lot of the professors, almost every professor I've had, And yeah, and my experience here has only backed up that interpersonal connection that was built on that very first day that I got a tour from the head of engineering. Every single one of my professors knows me by name. I have a connection with every single one of my professors, and I could walk up, talk to them, ask any question, ask them about their day, and I thank God for UT Martin because it is a wonderful experience I've had here.
Okay. In what ways do you believe the skills you're learning in your current research will be beneficial for your future career or for graduate school?
Go ahead. Well, so for me, this is exactly what I plan on doing in my career. And this is kind of a low pressure, low risk environment for me to be able to learn these skills. So as simple as the research methods, but then even going on to developing the scientific papers, taking my findings and putting them in a format that can be shared in the scientific community, and then going and presenting these ideas is something that I will have to do hopefully throughout grad school and then throughout my career. And I'm typically a person who has a lot of stress about things like that, so being able to learn these skills where I have all the support of the fantastic biology department here, any resources I could ask for, it's really a fantastic way to be able to learn how to do all these things and be successful, because this is what I plan to do for the rest of my life, so might as well get good at it.
Okay. Unfortunately, kind of hit on that a little bit earlier about the professional development, presenting in front of people. But not only that, the word I was looking for earlier was consulting. That was the word I was looking for, was consulting. Yeah, Dr. Nail, he does some consulting work where he outsources his engineering knowledge, and this was kind of a fruit of that consulting work. So in engineering, you can become an engineering and training EIT after you pass your fundamentals of engineering exam, and then 4 years down the road you can take your PE and become a professional engineer, which allows you to do consulting work. And the PE is kind of being a PE is in engineering field is kind of like the creme de la creme. It's the crown on top of the king. Metaphor. But it's getting prepared for that work, that consulting. It allows you to do that solo consulting work. Now, in the engineering field, of course, I'm going to be working with a firm, of course. But it is also a goal of mine to start my own firm and begin my own consulting journey. And this research that I did introduced me to kind of some of the aspects, how large of a scale, how many things you have to take into account when doing your own personalized work, because although we're just students, there is a level of accountability that must be maintained, and so that introduction to that level of accountability, kind of not so much pressure, but there is somewhat of a risk involved. So the pressure is there to get it correct and present your findings correctly and do the job right, and that definitely would drive me forward in my professional career.
I would say my advisors, like my research mentors, have really driven me to figure out what I want to do. They're like, Deja, make sure you got this, and this. Graduate schools require you this, and I'm like, okay, are you gonna write my letter of rec? And they're like, yeah, I'm gonna write it. And I'm like, okay, that's fine. And then I just chit chat. It's like you having a personal, not best friend. You don't want to say that because they're your PhD professors, but at the same time, they're your best friends personally. Me and Dr. Alexander always chit chat, and every time people see us, they're always like, "There's Deja and Dr. Alexander walking down the hallway. They're going to the laser lab, or they're going to go do research." And then somebody's always looking for me. Oh, I thought Deja was with you, no, or Dr. Alexander's with you. And I'm like, because we were always together trying to do research or something like that, and it's just like them helping you understand and helping you get through the path. They're like at the same time because they know you as a student. They've been through it. They've all struggled in undergrad, or none. Some of them haven't. They're like, okay, I've had friends that've done that before. Or like they understand. As a student, they at one point they were, and I've told them my struggles or what my fears are, and they're like, Deja, those are common, or don't be scared. That happens for every student, and that happened to me or something like that. So they make it personal, and then that, which is a great thing. And I believe that since I want to be a physicist, Dr. Alexander has been a great person for me, and he's been like my great advisor for applying to graduate school. He's just like, you know, a lot of people might say, since you don't have your baccalaureate in physics, you're not the same level as everybody else, but you worked as hard, you did the same work, you done actually probably more work than a lot of physics students who have their bachelor's in physics. You've done the research, you've put in extra time. It's just like, don't try to compare yourself to other students. Just think about how much you put yourself in and represent yourself the best you can to those other people at other schools, and we'll be the people behind you to help support you and make you look as good as you can. Like Deja did this here, and why we support her all the way. So basically, that's what it is. So yeah.
Great. Okay. So at UT Martin, we value experiential learning. Did your research give you any hands-on experiences? Some of you guys already mentioned a few of these. And if so, can you talk briefly about those experiences and what you got out of them?
Yeah. So for our research at the flood hazard study, so we actually got the opportunity. Dr. Nail took us down, and we actually conducted a site visit down there. And so what that involved was kind of going to our areas of interest in the Richland Creek watershed, and actually taking pictures, kind of gathering what data we could, kind of getting a layout for the land, and trying to get a gut feeling for kind of what it is we're actually modeling, because most of our research was actually computational. It's not. I'm sure it's not as materialistic and cool as lasers, but I mean, on a computer, most of it was on a computer screen. I guess those are considered lasers, yeah. But LEDs, but it was mostly computational. So a lot of the times, what our results yielded were just numbers, and what these numbers meant, what we could understand from these numbers, we had to kind of make sense of it, and getting the proverbial boots on the ground down in Richland Creek really hits home for what these numbers meant, and how our results kind of shifted. Whether we should change this aspect about our iteration, or should we change this? A number of things. But as far as experimental stuff, that hands-on, we got to go down there. We got to actually shake hands with the people we were doing the job for. That was one thing that Dr. Nail harped on a lot. Was actually in engineering. A lot of times in consulting, you could be in Memphis, Tennessee, doing a job for someone out in Nebraska. You could just go on Google Earth and see, like, oh, this is the land cover type at this area. Oh, this is how much rain they get. Oh, yada yada yada. But once you get down and you can shake hands with people, and you can understand what the people there are experiencing. This kind of draws back to how all people experience flooding. Well, this man we actually went up there and saw on a different area interest other than mine. So there were three of us in our group, and one of my buddies' area interest, there was a man there who actually dug out his own trench to drain some of the water away from this lake, because it was flooding up and washing away his land. So he dug out his own trench, and it's kind of stories like that you miss if you're just sitting there looking at the numbers. You can gain an idea of what these numbers mean. Just you can gain some sort of a gut feeling, but once there's almost like that personal connection. I don't know if y'all can tell, but I value that personal connection. And so when you get down and you can go on a site visit, you can shake hands with these people that are affected by what you are doing. It really influences you to generate the best work that you can, because these are people's lives that you could possibly affect. These are people's lives that you could have possibly hurt. And so in that sense, that's where the experimental part came in, and where it takes the cake for me.
So my project's very hands-on, definitely. So the essence of what we do is we go out to different sites where there's, so around this time, cottonmouths are going into hibernation for the winter. So we can usually find a large amount of them near their hibernaculous sites. So the project consists of going out, finding cottonmouths, catching them in a safe way so that, nobody gets bitten, everybody stays safe, and then doing various things to collect the data. So I'll just explain a little bit about how we do that. We catch the snake and put it in a tube where it can't turn its head back, can't bite, and we clean the snake off, and then we take a sample of its scales with kind of like a swab, and then we cap that off, take it, and that'll be analyzed in genetic research later on in the semester. But then we take several measurements for the snake. We take its length, its snout to vent length, its weight. We find its sex if we can. We list the coordinates of where we found it, things like that. And all of these things were completely unfamiliar to me. I had never done anything of the sort, but just getting kind of, even if it's not specifically what I will do in my graduate school research or in my future career research, just learning kind of those soft skills about how to be able to take a new concept or a new research method and figure it out in the field in real time. And getting that hands-on experience, really, you can't compare anything to that. You just kind of have to do it with a lot of stuff. So that's been very beneficial to me to get to learn how to do these specific techniques, but then also how to apply that sort of thinking process when I have to learn other techniques later on.
I think all the skills I've used from all disciplines of science has been a great thing. I think the most amazing thing is presenting this research to a bunch of professionals and talking to people from different schools and traveling to these different places and them asking you questions that sometimes you don't even think about, and you're like, oh, that's a good theory or good thing to test it on and like talk to, confer with. It's great things. I went to American Chemical Society in Illinois, and it was like a great thing. I talked to somebody who's a professional in nuclear chemistry about doing computational chemistry using density functional theory, and they gave me a card and told me to apply to their school when I'm ready to apply to graduate school. And I emailed them, talked to them, and they wanted me to come to their school and do a college visit. It's a great thing. And like I went to London and I presented my antiviral work. I've never been to London. I've never been outside the United States before, and I was able to talk to so many professionals. I was able to talk to Dr. Buma's own research mentor when she was in school, and he was talking about how great and amazing we were that as undergrads we were able to have this opportunity, and he thought of us as his grandchildren, his undergrad grandchildren. He was like, oh, my grandchildren are here to present research. He sat by us the whole time, wanted to take pictures, and he wants us to send our awards. He wants us to come to another conference with him, and he talks about us all the time. And Dr. Brim was like, oh, he just sent me an email asking how we were doing, how's the research going, great things. And it's just, I think, being able to present your research to such intelligent, amazing people or just a great skill as a professional and as a graduate student is amazing skills that we at UTM have since we do SINs here. It's a great thing. So like people from other schools or who don't know that some people do research here and they're like, oh, I want to get into research. Oh, I do research with this person. Yeah, you can talk to them, or we could join my project or something like that. It's a great thing here that a lot of schools don't do. So yeah.
All right, in what ways did being a transfer student, attending multiple institutions, help prepare you for your classes here at UT Martin and for the research you're currently involved in?
Well, for me personally, as I said before, I grew up in an extremely small town. And so when I was 18 years old, freshly graduated from high school, I was not in any way prepared to live on my own, in a city away from my family where I'd never been. So being able to have that year of going to school at Jackson State, but I was able to commute there, still being able to live at home and also being able to work during that year, building professional skills, building skills of independence, that was very crucial for me. And I do not think that if I had gone, whether it be to UTM or to another four-year institution directly out of high school, that I would have flourished as much as I have. So for me, it was critical to first be able to have that transition period and then to be able to go to a place where I could have my own independence and I could develop not only academic skills and professional skills, but just life skills to be able to, live on my own and provide for myself and do all of those things. So that was definitely, it was the best possible thing for me. And of course, everyone's experiences are going to be different, and it's all about, knowing what is best for you in your situation. But for me, it was absolutely crucial to do my education in this way so that I could have the best potential for success.
I think since when I went to Union, I was not able to do the same things I wanted to. I was limited by playing sports and having to fight and struggle to, hey, I need to take this class. Well, I don't think you can take this class because it does basketball. Well, in order for me to stay on track, I got to take this class. And there was just a fight and struggle. When I came here, it was just like a freedom of like, oh, I can take this class because I don't have anybody telling me no. I can continue to uh, strive for what I want and no pushback or somebody whispering in my ear, I don't think you could do that. I think you need to change your major because as an athlete, you probably won't make it because a lot of athletes don't make it in this field because it's basketball's in the way or something like that, or something like somebody just nagging your ear telling you can't do this. And I just feel like somebody being here, there's always somebody behind you talking about, yeah, you can do that, most definitely, we'll support you in a way, any way we can. And it's always really nice. So that's why I feel like UTM is very beneficial as that.
This is why I've been trying to answer first. Can you kind of restate the question, please?
So, in what ways did being a transfer student, attending multiple institutions, help prepare you for your classes here at UT Martin and for the research you're currently involved in?
Cool. I have an answer for that. So I think that a large sum of what you learn in college is how to diversify yourself. So you are trying to balance going to classes. You're trying to balance your personal life. You're trying to balance extracurriculars. You're trying to balance, church life. You're trying to balance all these things, and what that does, what attending multiple institutions does, is it adds to that diversity. So at Dyersburg State, that first year, graduated, COVID, online classes definitely quickened me very fast on how to deal and time manage very quickly. How to manage. Oh my goodness, I got all these online homeworks I gotta do. I gotta take pictures of all and submit it, and all that stuff. And then you get here, and it's along the same lines, but different also. So it's the same as in, okay, I still have to manage all these things. I still have to manage all this homework. I still have to manage all of my time. But now it's in person, and these people I'm seeing them face to face, and it's I'm able to build relationships face to face, because I think we can all agree that it's kind of hard to build that connection with someone when you're over a camera. And as faculty and staff, I mean, I'm sure y'all can appreciate us when we went back. Maybe you didn't, but I as a student, I definitely appreciated when we got off of online, and the time management was crucial. And so, as far as relating that to my research, we set deadlines for ourselves. We had goals that we wanted to meet, and not only attending multiple institutions, but also the kind of experience of going from a freshman to a sophomore to a junior, kind of experiencing that college track, and understanding this mentality of, okay, there's deadlines, we got to meet these deadlines. And once again, this draws back to kind of the professional aspect. We got to meet these deadlines. If we don't meet these deadlines, this has to be pushed back, then this has to be pushed back. And attending multiple institutions kind of inserted me into that mindset, I would say. Another big thing for me was paperwork. Filling out paperwork for 2 different colleges I thought was really tough when I first did it, but it's obviously I've kind of grown into that. So.
Okay. What advice do you have for transfer students who are interested in getting involved in research?
Talk to faculty. They are not scary. They love to teach. They want students. They want to teach research. They want students involved. That's a lot of them have great ideas. They just want students to be like, hey, I'm interested. Thank you. I'm ready to share my ideas. I'm ready to get people out there and doing it. And it's just, I tell people, I'm like, they're like, oh, I don't want to go talk to you. I'm like, okay, I will go gladly hold your hand and we can both go there. And I'm like, hi, my name is Dr. Deja. And I'm like, here is Landon. And here you go. Walk in there. I'm like, and then I'm like, push him in. Okay, I'm leaving. Bye. And I'm like, I've gladly done it before. Like, Dr. Boom was like looking for a research student, and I'm like, hey, are you interested in research? I don't know. I mean, I've never talked to her. I'm like, she's the easiest person to talk to. Like, let me introduce you to myself. I'm like, hi, hey, Dr. Boom. And she's like, hi, Deja. And I'm like, oh, here's Landon. He was interested in research, and they introduced him. I'm like, okay, well, I got class, and I leave, and then she's like, oh yeah, he wants to do research, and I'm like, yeah. All right, and then he shows up the next meeting, and then they're like, oh, they're a part of the group now, and then I tried. I'm like, yeah. And they're like, how do you do all these amazing things? I'm like, I talk to faculty. They're not scary. They're the easiest people. They're willing to talk about their research. They love talking about their research. Just need to go up and talk to them. So that's all I gotta say.
For me, it would be not only don't be intimidated by faculty, but also don't be intimidated by the research itself.
Yeah.
When I got the idea of doing a research project, I was terrified because I was like, I don't know how to do any of this. Like, and so I thought about it as this big insurmountable task. But truly, the faculty that do the project with you they will give you some independence, of course, but they will help you as much as you want to be helped, and so you're not on your own. They recognize that you are an undergrad. This is your first time ever doing this kind of thing. So they're always willing to work with you about how to learn these skills you need, how to manage the time, very flexible with those kinds of things. So I would say even if you're scared about it, just do it, just try it out. It really adds so much, and it really is not as scary as it might seem like at first glance.
They'll never set you up for failure at all, because they'll never put you in a position where you fail as a student. They want to support you, make you successful as a student. So they'll never put you in a position to fail. So that's one thing.
Absolutely.
Well, I would not only say do not be afraid of faculty and staff, not only be afraid of research, but I would also say don't be afraid of other students. So that influence, and other students can influence you. You know, it's very rare you're in a class by yourself. So when you have these other students and you see they're like, oh, well, what research are you doing? And they're like, oh, I'm doing this, this, and this, and this, and this. And they're like, oh, well, I don't really want to do that, but I'm kind of pressured a little bit to go in and do it with you, but I don't really want to do that. What I would say is no, do your own research if you want to do it. Don't let other people influence you in that sense, because this is, it's kind of like the whole adage, you know, if you enjoy what you do, then you won't work a day in your life. Well, if you're sitting there doing something that you don't want to be doing and you're just in it because someone else is in it, that will not go well for you. You're going to spend a whole year doing research that you don't even want to do, and then in the end, the results won't even matter to you because you don't care about the research. You don't want to do the research. But that's kind of something that I kind of could have fallen victim to, in that you know we had opportunities to do other things, and people did other things, and I didn't want to, and fortunately there will be a faculty and staff member that can help you, and I cannot iterate enough what they said. They will help you. They will not fail you. They will not fail you.
All right, so we have a few minutes left, so I wanted to see if there were any questions from the audience.
First, I want to thank you all for your presentations, and I want to say that I'm very proud to be associated with the College of Engineering and Natural Sciences. I'm glad all of you are in college. Thank you for choosing UTM. Um, so if you, as you finish up your projects, I know not all of you are towards the end, but as you finish up your projects, I'm going to give you a quick ad if you're not aware of it, which I know two of you are. But we are having an end of the semester, December 5th. We have an end of the semester event for our students to present their projects at Rasmussen. And I hope all three of you will be engaged in that. And,
You know I'll be there. I'm always there.
yeah. But as you finish up your projects, what types of plans do you have you worked with your faculty members about how you're going to present
So my project with Dr. Buma is basically finished. We just need to collect some more data and hopefully have a paper produced by this semester or next semester. Um, so the new project with Dr. Alexander and Dr. Buma is a new project. I'm building the laser this semester, and then the laser will be used next semester for her cell line. Um, this laser will be the component and the basic setup is going to be presented this December in SINS, and so it's just going to be the showing the end, me building it, the pieces, the components, the prices, and all that stuff, and how they're comparable to a LED. And my research with Dr. Thomas Ellington, which is a new project. It is a computational chemistry using understanding aromatic rings with different substituents groups with halogen bonding and XB acceptors and donors, which is a new project. I'm just the head leader on the group, and hopefully I'm going to pass it down to our freshman in the group. He's just learning, and so I'm there to hold his hands and make sure, hey, it's not scary. And I'm like, yeah, it's not. I've done it before. I told my previous advisor in computational chemistry, I don't know anything about coding. I hope you know that. And he's like, yeah, it doesn't matter. I'm just, you'll learn on the way. And I've done it, and I love it. And I've never thought I do computational chemistry. I didn't even know computational chemistry existed. And he's like, yeah, it does. And, it's amazing. I hope you know that. And I was like, yeah, I do. And so I think it's a great thing. And then in the springtime, we're supposed to go to ACS. I'm supposed to go to Tennessee American Association of Physics Teachers, which is here at Latimer, which is going to be held by Dr. Alexander at the physics department. And it's going to be different schools from they have physics majors come here, and they're going to present their research. And I hope to do that and collaborate with more people and talk to other graduate schools and stuff like that. So, yeah.
So for me, I just started my project this semester, so we're in the beginning stages for sure, and our plans are for this semester to collect samples from the cottonmouths, and then in the spring we're going to analyze those samples through something called PCR, which is polymerase chain reaction, and that's to look for specific DNA markers for the samples we got to see if the specific fungus we're looking for is present. And the plan is in the spring to go to ASB, which is the Association of Southeastern Biologists. It's a conference that takes place, it moves around the southeast, and this year it'll be in Myrtle Beach. And to go there and present a poster and maybe even a presentation, depending, about the research we've done. And then I hope to extend, I'll be doing this project the following year as well through my senior year. And hopefully I'll be able to go back to ASB once I've collected even more data and we have, a better view of what we're looking at, so I would like to definitely continue this throughout the next 2 years.
So my project, I was involved with a group of 3 total. There were two of my peers, Mr. Peyton Kitty and a Mr. Paul Atkins. We're actually all at 3 different stages, I guess. Our group completed our research last year. We started it last fall, and we went out. That last fall was when we first did that site visit. That was kind of the preliminary work to it. But as far as the structural breakdown of it, we identified a scope. We identified, the people who are at risk in this by doing this project. Then we identified computationally what needed to be done in the design phases of this research, and that involved mainly a computer program called HECRAS, which is basically a hydrologic modeling program. And so it was heavily iteration based. So we would sit there, I inputted, I was trying to model the river based on FEMA flood insurance maps on 100-year storms, which is a storm that occurs, probability of it occurring once every 100 years. So 1% chance that it rains X amount in that area. And so if my model would match up closely, if the flooding of the existing geometries or the existing terrain there matched up closely with the 100-year floods, then my base model could then be used to implement my solution. So the major solution that was involved in my particular area of interest, which was the confluence of the Richland Creek Richland Creek River and Pearl River, that confluence there where those two meet, uh, was actually the big solution that was brought to us by Dr. Michael Smith, which was one of the commissioners at Richland Creek Watershed District, was for channelization. Now that's kind of like a 1960s, 1970s thing that they channelized everything, but it was the major solution that he wanted, and I kind of came up with my own solution. So there was kind of three mindsets when coming up with these solutions. The first one was one where it was heavy machine based. It affected the environment a lot, so that was a big, deep, wide channel that could hold a lot of water, but in the end would then release all the water in the area. So what we found was that in using this big, huge channel, this short, basically stumpy, 50-foot wide, 15 feet deep channel, was that the flooding got brought down too fast. So it would pretty much drain that whole flatland area in that confluence area where the mouth of the Richland Creek meets the Pearl River. And then our second mindset was one that was not too endangering to the environment, but could possibly work. Kind of the happy medium. Not too hot, not too cold. Three Bears reference there, but not too hot, not too cold. So that was, in my mind, that was the one that I thought, I was like, yeah, that would work perfect. And so it was a little longer. It was a longer channel, but it was shorter. It was skinnier, not as deep, not as wide. And so what we found out from those results was that length actually, because a natural river, I'm sure we all know this, but a river bows and bends. And so when you cut a river straight, what is called the hydraulic energy actually goes up. So the water goes faster. The water then is not slowing down as much, because as it bends, it hits the side and slows down. It basically acts like a natural buffer. So that hydraulic energy increased, and what our models told us was that, yeah, it reduced flooding and it didn't do it so drastically, but however, this is where going back to beyond the numbers, because that hydraulic energy was high. Quick's not the right word. High. The water was moving quick. You are left with erosion, and erosion's a big deal right there, because water's going fast. What happens when water goes fast in sand? Takes the sand particles with it, and over time, you're gonna have less and less in land, and you're gonna have more and more river. So that was kind of the second mindset, and then the third mindset was kind of something that we had just in case channelization was deemed not applicable, not I don't want to say not worthy, but not applicable. We didn't want to do channelization. So what we then had an idea for was just because it was a wooded terrain. This is also going back to getting boots on the ground. Because it was a wooded terrain, the idea we had was, okay, what if you sat there and instead of channelizing it, what if you just cut some of the trees out and decrease the resistance for rain and flood water to get to the Richland Creek River? And so then if it's less resistance, then the water from the land, from the watershed, is going to flow quicker into the stream, and then therefore it'll be outflowed from the watershed quicker. So I kind of pitched that idea to him, and unfortunately we did not do any design iteration, so there wasn't any numbers to back that idea up. Although I thought it was a good idea, but we didn't end up doing it. But yeah, we finished all this stuff, and I compiled me and my two peers compiled a 80-page report, in total 100-slide presentation, and we actually got the opportunity to go back down to Richland Creek in the spring. I believe it was early April, or April 3rd, April 4th, that we got to present all these ideas, and that's when I was talking. We got to present these findings, and that's when I got to talk for an hour and a half straight, and I did a whole lot of breathings and mouth champing and all that stuff. But yeah, it was great. But that was kind of that was it. Yeah.
I just want to say I'm also planning to present at American Physics Society in Anaheim, California in March as well. So, yes.
All right. Dr. Norbert, do you want to do any closing
Yeah,
remarks?
maybe just to wrap up, if you would just once very quickly repeat the names of the faculty members who have assisted you in your journey, I think that would be a great honor to them.
So, I'm sorry. So the main professor that I'm doing my fall research with is Dr. Tom Blanchard in the biology department, and then assisting us with our PCR analysis in the spring will be Dr. Kevin Pitts, also with the biology department. So big shout out to both of them. They're both wonderful to work with and have been extremely beneficial to me in this project.
So who me and my peers did our research in this flood hazard study through was Dr. Gregory Nail with the Civil Engineering Department. He's got his PE in mechanical engineering as well as civil engineering.
I do my research with Dr. Violet Buma, who's a biochemist, Dr. Alexander, who is a physicist, Dr. Thomas Ellington, who is a P chemist, and Dr. Lionel Cruz, who is a astrophysicist. So yes.
Great. Well, thank you